Class 11, Chapter 13, Limits and Derivatives, Exercise 13.1. The first heading is Evaluate the limits for the following. There are 22 questions in this, 22 functions. We have to evaluate the limits for each of them. So before going ahead, we will first understand what is the meaning of limit of a function. Limit of a function when x tends to a. So we will understand this. What is limit value? What exactly is left hand limit and right hand limit? We will understand this with the help of the first question from this exercise, that is limits x tends to 3 and the function limit x tends to 3 x plus 3 or limit of any function can only exist if left hand limit is equal to right hand limit. So how do we write left hand limit? That is limit when x approaches or x tends to 3 minus is equal to limits x tends to 3 plus x plus 3. So minus indicates left hand limit, plus indicates right hand limit. Only if both are equal, we say that limit exists. And if one of them fails, we say that limit does not exist. And if they exist, what value we obtain from calculating left hand limit and right hand limit will be the value of the limit. So we got the value as 6, right? That means 6 is the value of both left hand limit and right hand limit. So we will understand this by drawing x plus 3 in the graph. Here is the graph of the function, x-axis, y-axis, and the linear function x plus 3. This is linear because the degree of this variable is 1. Since the degree is 1, we will get the straight line. And to draw a straight line, we just need 2 points. 2 points are sufficient, right? So let us give 2 points, one from the origin 0. So if you give 0, the output will be 0 plus 3, which is 3. So the point will be 0, 3. X-axis, y-axis. Now let us give another point 1. So if you give 1, x equal to 1, 1 plus 3 is equal to 4. So the another point is 1, 4, 1, 4. So 1 is from the x-axis and 4 is from the y-axis. The first point is from the x-axis and the second point is from the y-axis, right? So the bottom of the limit, that is x tends to 3, this is observed on the x-axis. Like if you have x tends to 1, x tends to 4, x tends to 5. So whatever value they have given, you have to observe this on the x-axis. Okay, and whatever the outputs that we get or the functional value that we get, that we will plot on the with the help of y-axis. To understand left hand limit in the graph, so we will approach 3 from the left side. That is, we take all the values of x that is lesser than 3 but very close to 3. It can be 2.9, 2.99, 2.8 or 2.999. So all these numbers you will find to the left of 3. So when I say x approaches 3 minus, that means I am approaching 3 from the left. Okay, and when I am approaching 3 from the left, I have to check what are the values that I get on the y-axis or the functional values. So when I gave input 1, I got 4. What if I give 2.9? What will be the output? if I give 2.99, what will be the output? So we are going to see the numbers that are very close to 3, and we will check what are the output values we will get. Okay, so here is the table, and the input x from the x-axis and the output x plus 3 from the y-axis. Okay, we will see what is the value that we are going to get. Let us approach 3. Let us approach 3. Let us say that we have taken a point 2.9. Okay, 2.9. So if you give 2.9 to this function, so the value will be 2.9 plus 3, which is 5.9. Okay, 5.9. Somewhere you will get 5.9 here. Now we'll get even more close to 3. Let us say the value is 2.99. It's very close to 3 compared to 2.9. Now what is the output? The output will be 5.99. Okay, 5.99. So let's get even more close to 3. So what will be the output? The output will be 5.999. So here it will be 5.999. So if you observe the pattern here, if you approach 3 from the left, so what is happening to the functional values? These values are approaching to one number, 5.9, 5.99, 5.9999. It will be 6, right? So these numbers are very closer to 6 if you observe here. Right? So if you approach 3 from the left, the outputs are approaching towards 6. So what we can write here is, when the limit, the values, input values approaching 3, the output values are approaching 6. So we got the left hand limit value, that is 6. Now let us check whether the right hand limit is also equal to 6 or not. Right hand limit x tends to 3 plus. Okay, now let us approach 3 from the right side. That is, you approach 3 from the right side, the numbers greater than 3, but it has to be very close to 3. It's not like 4, 5 like that. The number that you take as an input must be very close to 3. So what happens if we approach 3 from the right side? Let us say the value we have taken is 3.01. This is quite closer to 3. So what will be the value on the y-axis? 3.01 plus 3, which is 6.01. So this value has to be above 6, right? The values are above 6. So it will approach 6. So if you approach from right side, the graph is falling downwards. Now let us give another value which is more close to 3, even more close to 3 than 3.01. So it will be 3.001. So this number is quite close to 3. So what will be the output value? 3.001 plus 3, which is 6.001. So if I give the value 3.001, the value will approach to 6.001, even more closer, right? Now let's give another input, 3.001. This number is very close to 3. So what is the output that you will get? 6.0001, right? So you will get the value which is even more close to 6 than the previous value. So what do we observe? So if we approach 3 from the right, so what's happening to the outputs or the functional value? It is approaching 6, because this number is very close to 6 compared to 6.001. So if you keep on approaching 3, these values will also approach 6. The thing is, we will not find what is the value at 3. That is not the concept here. The thing is, we have to approach 3 and we have to check, is there any constant number where both left hand limit and right hand limit will approach. Suppose if it does not approach, then it might approach to some other value like this. Then we say limit does not exist and we will get the different value here. But in this case, the value is approaching to one single number, that is 6. Right? So if you observe here, so here also it is 6. So left hand limit is equal to right hand limit. So if left hand limit is equal to right hand limit, we say limit exists. And what is the value here? What is the value we have to write? 6. And that is what we wrote in the first step, that the value of limit is 6. So it could be the direct substitution, because you give any polynomial function, limit will exist, so we can directly substitute and write. But the idea behind this value is the left hand limit being equal to right hand limit. If one of them is not equal, if one of them does not exist, or if this is 6 or this is 7, then the limit will not exist. Okay, so here this arrow is the most important thing. It indicates that you're approaching 3 from the left, from the right, but you will never give the value 3 there, right? You never stand at 3. You just approach and check whether the outputs or the functional value will approach to the same number. So with this, we will solve the further exercise problems. Let us solve the exercise problem. First question, limit x tends to 3, x plus 3. We have to find the limit value here, right? In the previous, I have explained how did we get the limit value, that is left hand limit and right hand limit. But every time we will not do this while solving the problems. We have certain mathematical statements and we have certain theorems and properties by which we will directly solve the problems. Okay, so I will be using those properties and theorems and some statements to approach the solution. So first, what we have to find here, we have to find the limit value. So let us write down given. First we will look at the function. The first function they have given is x plus 3. Given p of x is equal to x plus 3. Now this is a polynomial function. Polynomial function, right? Now how do we find the limit of the polynomial function? When limit x tends to a, p of x is equals to p of a. Right? Limit value is equal to functional value. Now if you compare the given and the statement, limit x tends to, in the place of a we have 3, in the place of p of x we have x plus 3 is equal to p of 3. Now our aim is to find this p of 3. How do we get p of 3? From the given function, right? So we know that p of x is equal to x plus 3. So p of a will be, that is p of 3. P of 3 will be 3 plus 3. So therefore p of 3 will be equals to 6. So now let us substitute the value here. Therefore the final solution, that is the final limit value, is p of 3 is equal to 6. So which theorem or statement that we have used here is, limit of a polynomial function is equal to the functional value. The second question, limit x tends to pi x minus 22 by 7. First, what we have to find? Limit value, right? For that, we will check what is the function they have given here. Given is a polynomial function p of x is equals to x minus 22 by 7. And what is the limit value for a polynomial function? Limit x tends to a, p of x is equal to p of a. So let us compare here. In the place of a we have pi, and in the place of x we have x minus 22 by 7 is equals to p of pi. Now we have to find the value of p of pi. We will find with the help of p of x. So this implies p of x is equal to x minus 22 by 7, and this implies p of pi is equals to, in the place of x we will write pi minus 22 by 7. So therefore limit x tends to pi, x minus 22 by 7 is equals to pi minus 22 by 7. This is the solution. Question number 3. Limit r tends to 1, pi r square is equal to. Okay. Now the function is in the form of pi r square. They have not given x like how it was in the previous sum. They have given r. So if you observe this carefully, this is radius. This is area. So radius tends to 1. Area of the circle approaches to what value? So that we have to find out. Okay. Given p of r, because in the previous question it was x, so we will write x here. So what independent variable they have given, we have to write that. So p of r is equal to pi r square. Okay, pi r square. Now limit x tends to a, p of x is equal to p of a. Limit value is equal to functional value, and we get this value from the function itself. Okay, so we will use this to solve. Now limit, let us compare these two. So in the place of x we have r, so we will write r here, and in the place of a we have 1. So where they have given a as 1, so we will write 1 here. And in the place of p of x, that is p of r, we have pi r square is equal to p of a value is 1, right? We have written 1 here. So let us write 1. Now our duty is to find p of 1 here. So how to find p of 1? That is to find the value of p of 1. P of 1 is obtained from the function itself. See the pattern, it is p of 1, p of r. So we can get this value from p of r itself. So p of r is equals to pi r square. So p of 1 is equal to pi times 1 square. So this implies p of 1 is equals to pi times 1 square is 1. So therefore p of 1 is equals to pi times 1 is pi. So we got p of 1 is equal to pi. So what is the final conclusion? That limit when radius tends to 1, the area of the circle will approach pi. So this sum can be solved directly, like limit x tends to 4. We will separate here 4x plus 3 divided by limit x tends to 4 x minus 2, right? Now this will be equal to, we will substitute directly 4 times 4 plus 3 divided by 4 minus 2. So this is 19 by 2. So the 19 by 2 is the limit value, right? But let us understand how did we approach from this to this. Okay, so in the exam you can write in this way, but let us try to understand how can we approach from here to here. See, the given function here is a rational function. Okay, so rational function, that is p of x by q of x. So in the numerator the function is 4x plus 3. In the denominator the function is x minus 2. So p of x by q of x. Now we want to solve the limit value for this. Like when the input approaches 4, what is the value of the function, right? This is what we have to solve. So we have limit x approaches a, p of x by q of x. It is a general form. So when you have rational function of this form, you will write limit x tends to a p of x divided by limit x tends to a q of x. So how you can write here? Limit x tends to 4, 4x plus 3 divided by limit x tends to 4, x minus 2. Now this is the same, this is the concept same here. That is what we studied in the question number 1 and 2. This is a polynomial function and this is the polynomial function, right? So limit x tends to 4, 4x plus 3 will be equal to, we'll write directly p of 4, right? P of 4. And how you will get p of 4? You substitute directly here, that is 4 times 4 plus 3, which is equal to 19. So here we will write p of 4 divided by, to solve this we'll write q of 4. Why we have written 4? Because you have taken p of x here, but in the place of x we will substitute 4 because this is polynomial function. Now this is equal to, now we'll solve the denominator. X tends to 4, x minus 2 is equal to q of 4. Okay. Now this equal to, so in the place of x we will write 4, 4 minus 2 is 2. So therefore numerator is 19 and the denominator is 2. So when you have polynomial function, in the place of the independent variable x, you can directly substitute. Therefore, limit x tends to 4, 4x plus 3 divided by x minus 2 is equal to 19 by 2. This is actually the way you are going to get the answer. Now the fifth question, limit x approaches minus 1, x to the power of 10 plus x to the power of 5 plus 1 divided by x minus 1. Now even this is a rational function, polynomial by polynomial. So we will write limit x tends to a p of x by q of x is equal to limit x tends to a p of x divided by limit x tends to a q of x, right? Now this is equal to p of a divided by q of a. Now we will write this one, limit x tends to minus 1, x to the power of 10 plus x to the power of 5 plus 1 divided by x minus 1 is equal to limit x tends to minus 1, x to the power of 10 plus x to the power of 5 plus 1 divided by limit x tends to minus 1, x minus 1. Now this step we have to write, that is p of minus 1 divided by q of minus 1. Now substitute minus 1 here. It is minus 1 to the power of 10 plus minus 1 to the power of 5 plus 1 divided by, now substitute minus 1 in the denominator, minus 1 minus 1. This is equal to, We know that minus 1 to the power of even number will be equal to plus 1, and minus 1 raised to odd will be equal to minus 1, right? So we'll take one example, minus 1 square. So I have taken even number. So minus 1 times minus 1. So minus into minus will become plus 1. So no matter it is 400, 2000, 1000, any even number you give, you will get positive number. Now let us take one odd number, 3. So minus 1 into minus 1 into minus 1 will be equal to minus into minus will be plus 1. And this is equal to minus 1. Now this is equal to plus into minus is minus 1. So if you give if the power is odd here, then you're going to get negative. So here we have even number, 10 is even number we'll get 1, and here it is odd number, we'll get minus 1 plus 1 divided by minus 1 is 2. Plus 1 and minus 1 will get neutralized, you will get 0 plus 1 divided by minus 2, and 0 plus 1 is 1 divided by minus 2. So therefore we get limit x approaches minus 1, x to the power of 10 plus x to the power of 5 plus 1 divided by x minus 1 is equals to minus 1 by 2. That means when this function, when you draw the graph of this function and when you select minus 1 on the x-axis, and if you approach minus 1 on both the sides of the function, this graph will approach minus 1 by 2. The sixth question, limit x tends to 0, x plus 1 to the power of 5 minus 1 divided by x. Okay, now this problem appears little different, right? Because we cannot give 0 in the denominator. So what happens if we give 0 in the denominator? So it is in the place of x I'll give 0. 0 plus 1 to the power of 5 minus 1, and in the denominator it is 0. 0 plus 1 is 1. 1 to the power of 5 minus 1 by 0. And finally this is 1 to the power of 5 is 1 minus 1 by 0. 0 by 0. This is 0 by 0 form. This is undefined. Right? This is undefined. So this problem cannot be solved in this method. We cannot solve in this method. Like taking numerator and denominator separately. Why? Because even if you give minus 1 here, minus 1, you will get minus 2 in the denominator, which is fine. But in this we are getting 0 in the denominator, right? We are getting 0 in the denominator. So this cannot be solved in using the previous method. So whenever we have certain different type of questions, we always have a background theorem, statements or proofs to solve. So the prime thing is you have to learn those basic things first. If you learn those theorems, if you learn to handle the question and to identify and to tackle the question in a right way, then you can solve it. So you cannot do this in the previous method, but we have a proof. We have a mathematical proof for a statement that we will see now. See, you have limit x tends to a, x to the power of n minus a to the power of n divided by x minus a is equal to n into a to the power of n minus 1. So when we have a situation like this, limit x tends to a, x power n minus a power n and x minus a, then we can solve this sum very easily by substituting n into a to the power of n minus 1. That we substitute the value of n and we can substitute the value of a and we can get the limit value. This is our main purpose, right? We have to solve this. We have to get the answer, right? But this is not directly given here. but they have given the value n value as 5, but here it is binomial x plus 1, but here it is monomial x, correct? And here we have binomial x minus a, but here we have just one single variable. Now our duty here is to shift this question or to change the question in this format so that we can apply the solution. Now we will change this in this format and we can write like this. Now you might think, how we will know that we have to apply this statement only? How will we apply this? If you observe carefully, now this is in the form of this number is a rational number, right? Here also you have a rational number. Okay, so when you have like a rational function and you have a rational number, you can think of using this. This is nothing but the division. Okay, this is dividing this polynomial by a linear divisor that you can check in the proof. But one key thing that you can observe is when you have undefined, think of using this method. You have to bring this question in this format and then you have to use this. Okay. Yes, now let us change this function, pattern of this function. So here we have binomial x plus 1. So what we will do here is, we will make this into one single variable like this. For that we will introduce a new variable. Let us say we will replace this. Let x plus 1 be equal to y. Single variable. Now this entire binomial became monomial, right? Y. So we are introducing new variable here. New variable. So whenever you are introducing new variable, you have to bear in mind that you're supposed to change the other variables also in terms of new variable. So wherever there is old variable, you have to change it in the form of new variable. That is, you have to change x tends to 0. You have to change this also. So you have to change this and this. This we already introduced this with the new variable. Now we have to change this x tends to 0 and x. How to change these two? We will change these two by taking this x plus y equal to x plus 1 equal to y. This will help us to change x tends to 0 and x. Okay, so let us write this once again. Now if we just change LHS and RHS, it will be y is equal to x plus 1. Now first we will change x tends to 0. When x tends to 0, so when x tends to 0, when this number approaches 0, what will happen to y? Y will approach 1. It is polynomial, directly you can give 0. When x tends to 1, x tends to 0, y tends to 1. Okay, so we changed this x tends to 0 as y tends to 1, and here we changed y to the power of 5. Now in the denominator, how we are going to change x? Here x will be equal to, if you just shift this, y minus 1. Now we also changed the denominator, y minus 1. Now if you observe, these two aren't the same. X power n minus a power n divided by x minus a. Okay, so when we introduce a new variable, we have to change other terms which involves old variable. Involves old variable. Okay, so since we introduced y here, we have to change, wherever there is x, we have to change it with y. And how we will change it? With the help of the equation where we used x plus 1 equal to y. Now let us write the new format of this. So in the place of x tends to 0, we will write y tends to 1. In the place of x plus 1, we will write y to the power of 5 minus 1 divided by, in the place of x, we will write y minus 1. One small thing we will change here. See here we have a to the power of n, right? But here it is just a. So how can we write 1 here? It's very simple. 1 to the power of 5 is equal to 1. So instead of just writing 1, we can also write 1 to the power of 5. There is no difference, right? Now can we directly apply this? We brought this entire thing in this format. Now we can directly apply this. Now this is equal to, in the place of n, we have 5. In the place of a, we have 1. 5 minus 1. This is equals to 5 into 1 to the power of 5 minus 1 is 4. And 1 to the power of 4 is 1. And 5 times 1 is 5. Right? So therefore, when limit x tends to 0, x plus 1 to the power of 5 minus 1 divided by x, what happens? The value will approach 5. Question number 7. Limit x tends to 2, 3x square minus x minus 10 divided by x square minus 4. Right. Now you will think that this is a rational function. And just now we had two methods of solving rational function. P of x by q of x. We'll apply limits separately. We'll take the functional values, right? And there was also another method when you have rational function. You bring in this format and you get the value. But you have to think whether we can apply this or this. Before that, you have to substitute the value 2 and see whether which formula we can apply. So first we will directly solve this. 2 square minus 2 minus 10 divided by 2 square minus 4. Now this will be 2 square is 4 minus 2 minus 10 divided by 2 square is 4 minus 4. Now this will be 12 minus 2 minus 10 is minus 12. 4 minus 4 is 0. This is 0 by 0. This is undefined, right? So when you cannot give directly, that means we cannot apply this one. Okay, can we apply this format here? We cannot apply this format here. Why? Because if you want to apply this format, the degree of x here should be 1. This should be a linear factor here, x to the power of 1, but here you have x square, so you cannot even apply this. Is it possible that we can change this and bring it to any one of the format? That we will solve now. Okay, now if you have quadratic, it is very easy to factorize and reduce and simplify it. Okay, so let us factorize this one. 3x square minus x minus 10, we will equate it to 0. Now if you solve this 3x square, we will factorize this. Minus 6x plus 5x minus 10 equal to 0. Now you equate x minus 2 plus 5 into x minus 2, which is distributive law. Now if you write here 3x plus 5 times x minus 2 equal to 0. So we changed this entire equation into two factors. So in this numerator, we will write these two factors. Okay. So limit x tends to 2. So 3x square minus x minus 10, we will write 3x plus 5 into x minus 2. Now here also there is quadratic. We can factorize this. X square minus 4. So this is very similar to a square minus b square. Correct? A square minus b square, because we can write this as 2 square. So x square minus 2 square. And a square minus b square is a plus b times a minus b. So x plus 2 times x minus 2. Okay, so here in the denominator we can write x plus 2 times x minus 2. So whenever you have quadratic, you think of factorizing it. Okay, now this implies limit x tends to 2. See, x minus 2 is in the numerator, x minus 2 is in the denominator, so we can cancel them. So x minus 2 by x minus 2 will be equal to 1. We can cancel it. So what are the remaining terms here? 3x plus 5 divided by x plus 2. Now again you got rational function. Again you got rational function, right? Now we will see whether we can apply this one or this one. You might say that, okay, the degree of this variable is 1, we can apply this. No, still we cannot apply. Why? Because we don't have this rational power here. Okay, and we don't have same terms here. Like here also a and a. We don't have a and a here, right? So we will use this first one, which is very simple. That is, this implies limit x tends to 2, 3x plus 5. We'll keep this here so that it will be easy for you. And denominator, we will write limit x tends to 2, x plus 2. Now this will be equal to, we can substitute directly because we know that. We'll write here limit x tends to a, polynomial function is p of a. So we will give, this is the reason why we are directly substituting. So now we can write 3 times 2 plus 5 divided by 2 plus 2. Now this will be equal to 6 plus 5 divided by 4. So the solution here is 11 divided by 4. Therefore, so the original question was limit x tends to 2, 3x square minus x minus 10 divided by x square minus 4 is equal to 11 divided by 4.